In this video, I am going to solve this system of linear equations using the substitution method. Here is my system, this and this. This system has two equations with two unknowns x and y. Before I solve this system of linear equations, let me give you an idea of what it means to solve a system of linear equations and find the solution. So let's consider this scenario. You have just some arbitrary line L1 and another arbitrary line L2. This is just a sketch. It has nothing to do with this system, just general overview. Now, when you are solving a system of linear equations, what you are doing, in essence, you are finding the coordinate of this point of intersection. So let's call this A, B. So when we are solving a system of linear equations, we are finding the point of intersection for the straight lines. That's exactly what we are doing. In our particular example, we have two straight lines. So when we are solving this system of linear equations, we are finding the coordinates, x coordinate and y coordinate of the point of intersection, which is this point. Now that we have kind of outlined what we are going to look for or what we are finding, let me go ahead and use the substitution method and solve this system of linear equations. Now, if we look at this system, the first equation does not have x or y by itself or with a coefficient of -1, but the second one does. So second one has x with a coefficient of -1. And in the second one, we are going to solve for x and then take that x value and plug it into the first one. So in the second equation, if we solve for x by subtracting 3y from both sides, what we get is this -x. This -3y and +3y are going to cancel, and that's going to give me on the right hand side -3y plus 4. Now I am going to multiply both sides by -1. If I did that, on the left hand side I am going to get x. -1 times x is just x, and on the right hand side -1 times 3y is going to be 3y, and the -1 times 4 is -4. So just to remind you, I am multiplying both sides of the equation by -1. Now this is my x value. Now I am going to take this x value and plug it into this equation, where -4 times x, but instead of x I am going to put 3y minus 4 plus 5y is equal to 1. Now use the distributive property. -4 times 3y is -12y. -4 times -4 is +16 plus 5y is equal to 1. Now -12y plus 5y is -7y plus 16 is equal to 1. Now I subtract 1 from both sides, 16 from both sides. Then I get -7y, +16, -16 cancel out, is equal to 1 minus 16 is -15. Now I divide both sides by -7, divided by -7. -7 and -7 cancel out, that gives me y on the left hand side, and on the right hand side this negative and this negative cancel out, that gives me 15 over 7. So that's my y value, 15 over 7. Now I can take this y value and plug it into this equation. That's going to give me my x value. So x is equal to 3 times y, but y is this, is going to be 3 times 15 over 7 minus 4, which by the way is equal to 3 times 15 is 45 over 7 minus 4. Now I am going to multiply 4 by 7 and divide it by 7 so that I have the same denominator. So that's going to be giving me 45 over 7 minus this 4 times 7 is 28 divided by 7 is equal to 45 minus 28 over 7, which is equal to, by the way, 17 over 7. So my x is going to be 17 over 7. Now I just found the x and y. So my pair is going to be x comma y is equal to 17 over 7 comma 15 over 7. Now let's sketch it and show you what's going on. So let's say this straight line kind of looks like this, and this straight line kind of looks like this. Now we just found the point of intersection. We just found this point of intersection, which, by the way, is 17 over 7 comma 15 over 7. So in essence, when we are solving a system of linear equations, we are finding the point of intersection, meaning finding the coordinates of the point of intersection. I hope that this discussion was helpful. Thank you very much.